So welcome everyone to today's webinar on Fusion 360, make it with CAM and 3D printing, or make it with 3D printing and CAM. My name's Matthew McKnight. I'm a technical specialist with Autodesk, and thanks for joining us today. A little bit of the formalities, my contact details up on the screen there. If you would like to contact me after the session or engage with me in regards to some of the content that we're about to deliver, feel free to reach out. My email and phone number there, and you can also get me on LinkedIn, and I'm occasionally on Twitter. Otherwise, let's talk about this is the last in the core series of Fusion 360 webinars that we're conducting over October. Doesn't mean that we won't be holding more webinars. We will be, the next of which is early to mid-November, Fusion 360 for SolidWorks users. So if you're a SolidWorks user and you want to learn a little bit more about the differences and how it can work with a SolidWorks workflow, or you're looking for an alternative solution, then feel free to sign up for that webinar. So our agenda for the day, because we have quite a lot to get through, we'll start off just talking a little bit about what Fusion 360 is. We'll then introduce a little bit about Fusion 360 CAM. We'll talk about 3D printing in Autodesk and what Autodesk is doing in the 3D printing space. Then move into 3D printing in Fusion 360, or with Fusion 360, maybe that should say. We'll talk a little bit about where you can get further information after the session, and hopefully have some time to answer any of your questions. Otherwise, let's jump straight into it. So what is Fusion 360? Well, Fusion 360 is one system, one user interface. It brings together all of the common tools that you would use as part of your design engineering workflow, and it incorporates them into the one user environment. So you can design, draft, analyze, or test your components, and then specific to today's webinar, you can then fabricate your parts as well using the technology. You can work anywhere. The Fusion 360 is device independent, meaning it's you've got a choice of platforms. If you're a Windows, or maybe you're an Apple or Mac user, then you can use it on either, and you can access your data using tablet and your mobile phone. So no matter where you are, you've got access to your files. And it also looks at a different way of collaborating with your customers and users of your products as well. So gone are the days where CAD guys are stuck away in a shed out the back of the manufacturing facility. They're actually more often front of house now, and they're talking with customers much earlier in the design stage. So long before a product is actually possibly even modeled, we're engaging with our customers to get feedback on their design criteria, what are their requirements, so that they can be brought into that design process much earlier. And that's what Fusion 360 offers you. It offers you the ability to be able to collaborate with users, customers, and interested parties much earlier in that process. Okay, so let's briefly do an introduction to Fusion 360 CAM. So why Fusion 360 for CAM? Well, there's a number of reasons, because Autodesk has really redefined the way that CAM is being delivered. In recent years, they've invested heavily in purchasing or acquiring technology and then implementing it into various platforms to bring this to you, and Fusion 360 is just one example of that. If you look at Fusion 360 in isolation, it's the only CAM solution that brings together CNC programming, simulation, design, drafting, real-time collaboration, and with online capabilities. There's no one else out in the marketplace that offers these types of integration. This means that you'll be able to work on all of your familiar CAD formats, making you productive right from the start. And then it's also redefining the way that you purchase this. So you can purchase monthly subscriptions if you want. There's no upfront fees, and then there's no fees for things like standard posts. So When you want to implement CAM into your workflow, then you can access a standard post from the post team, the Autodesk post team, at no additional cost. Further to this, it's the flexibility as well. So Fusion 360 breaks down the barriers of traditional CAM to CAM workflows by giving you access to CNC programming tools. So designers now have the capabilities of accessing these tools. You can import files in a variety of different formats, and it's available, as we said before, on a number of different platforms, including PC and Mac. So you've got your choice there in which one you prefer to use. Again, referring to the collaboration, because it is a big part of Fusion 360. Fusion 360 offers powerful collaboration tools. These enable you to bring people and ideas together in a collaborative platform where team members and partners and customers can comment and edit, update versions, look through old versions, and work together on important design and manufacturing tasks. And then if we look at the final area that, I believe that there's a lot of value for people when looking at Fusion 360 for CAM, is that the CAM capabilities, the quality of the tool itself. Fusion 360 actually uses the same proven CAM kernel as comes with HSM Works and Inventor HSM, a product that's available for Inventor users, which enables you to quickly generate your cutting tool paths, reduce your cycle times, reduce machine wear and tool wear. But it also enables you to produce parts of the highest quality as well, and we'll talk a little bit about that too. So talking about adaptive clearing is a technology that's available inside of Fusion 360. It's a roughing strategy that's different to the traditional roughing strategy. So here you see traditional roughing strategies where we've got a machine tool and we're just using effectively the tip of that tool to mill away material from our part. Typically that's done to try and reduce tool breakage, but it's at the consequence of tool wear and time to machine components. So adaptive clearing uses a high efficiency roughing where we use the complete tool, and the maths behind this process mean that the tool has constant engagement and constant load. So rather than getting spikes associated with changes in corners and transitions, this is minimized using the adaptive clearing technology. Here's a quick video that highlights and shows you some of the capabilities in this area. This is a large industrial machine, CNC milling machine that was programmed using a toolpath generated from the CAM technology that we're about to show. So, and you can see here that using adaptive clearing, that in a few seconds we can very quickly machine out or mill out large volumes of material, at the same time minimizing the chance that we're going to break tools, minimizing the wear on the tools, and minimizing the machine runtime. So we're getting the best efficiency out of our equipment. Okay, let's go on and have a look then at today's technical demonstrations. The first I'm going to start off with is the milling content, which will step through job setup inside of Fusion 360. We'll then look at generating some tool paths. In specific, we're going to look at some operations such as facing and adaptive clearing, 2D contouring and pocket operations. We've got some drilling operations and circular operations as well. We can then look at how we can simulate our tool paths, and we'll probably do this right through the process. It's not something you typically do right at the end. And then we can create our setup sheets and generate our G-code as well. So let's just jump straight into Fusion 360 and have a quick look. So I'm in Fusion 360, and let's go into our data panel because this is where all of our content is for today. So I'm just going to open up a file again, recalling that this information is synced across devices. So I'm logged in under my name inside of Fusion 360 If I jump onto my phone or my tablet or onto another computer and log in using my Autodesk ID, that will result in me being able to see exactly the same content and access this fairly much the same information that I can in this instance. In this case, what we do is we've got an accelerator lever off of a larger demonstration set that we have, and we want to machine that component out of a block of aluminium in this case maybe. In this instance, we've actually got a model of the machine bed, and the device is going to be, or the device is going to be holding the component. And we also have modeled in there some parallels that will actually show us where our material is going to be supported. So we'll support our blank material inside the vise, sitting on top of the parallels. And so let's step through that process. So in the first case, what I'm going to do is I'm actually going to hide all of the other components. I just want, really they're just there for a visual tool to enable me to see. Now I could actually, what I'll do is I'll leave them on for the moment and at least go through the first step. So the first step in our CAM setup here is, if you're in the modeling environment, remembering that Fusion 360 has a number of different workspaces, I can switch into the CAM workspace by going right down to the bottom of our options here, or workspace options, and go into CAM. And this brings me inside the CAM environment or workspace where I've got access to all of my CAM tools. The first is, and it's typical that you would follow it across in a logical order. In this case, I'm going to start with the setup. So let's create our setup, and my dialog boxes are typically jumping off to the other side of the screen. So let's have a look at how we create the setup. So in the first case, under the setup area, we've got the option for the type of machining processes that we're going to be generating. So in this case, we've got an option to do some milling, some turning, or mill turn. Fusion 360 has the capability to do both. And also we can do water, laser, and plasma cutting. Now I'll show you how you get access to that a little bit later on, but by default you may not actually see that water, laser, plasma option in your option dialog box. So in this instance, we're going to start out by milling. And the first thing I'm going to do is you'll note that the model environment setup shows that our stock is actually as big as our machine bed, and that the problem is that Fusion 360 at the moment is assuming that all of our geometry inside this environment is going to be machined, but that's not the case. But thankfully we have the option here of choosing the components that we want to machine. So in this instance I can click on nothing and then click on the individual component or components that we want to machine. So in this component I just choose the lever, which I have, and the next thing I'm going to do is, you'll note in doing so that we now have a coordinate system that represents the coordinate geometry of our or coordinate system setup of our machine and component. Now that may not necessarily reflect your setup. In this case it doesn't reflect ours either, because Z is actually in the wrong direction. We want Z up and down. So the way that we can do that is change the work coordinate system by selecting, in this case, the Z-axis and an X-axis. So if I want, I can choose the top face that will define the Z-axis, and then I can choose an edge, and it can be any edge. It doesn't have to be an edge of the component that we're machining, but it could be an edge of the component of a component within inside that environment, and just go OK. And you can see here now we have our stock. Now the next thing I'm going to do is just choose the origin. So I can choose the origin based on a number of different options. I can have the model origin, I can have a selected point, so I could choose a point on the part, I can choose the stock box point, or I can choose the model box point. The stock box and the model box point will become a little bit clearer in a moment. So I'm just going to choose stock box point and select this top left corner there. So you'll see that we now have our Z-axis up, X-axis, Y-axis. Now the other thing I want to show you is, if I go to stock here, I've got a number of ways of defining the stock material that we'll be machining this from. So I can use a fixed size box where I specify its width, depth, height. But then I can also go through and maybe choose a relative size box. So the relative size box will adjust with the component adjusting. So coming back to the associative one tool, one system environment, if we were to go back and make a design change to this component, and after we'd set up our simulation, it would automatically update as well. So in this case, I can create a relative box size and then add some offsets associated with that. So in this case, I've got a 1 mil offset to the side, a 1 mil offset to the top, and in the bottom we want to actually add a little bit more offset than what we've got. You can see here that we've got a little bit of room and we want to add some material in that area. So in this case I'm going to add a 10 mil offset to the bottom of the part, and you can see then that our stock now extends down further than what it previously did. Otherwise I can go OK, and you can now see that we've got our setup has been added to the operations in the tree. Now this is the stage where I can hide all of these other components. I don't necessarily need them. We're just going to work on our part. Now the first operation, and predominantly today we're going to be focused on 2D milling operations, but Fusion 360 will do 2D or 3D milling operations, and there's suggestions in the future that will be there will be 5D milling operations will be added to Fusion 360. I can't exactly say when, but there is a lot of chatter that possibly 5D will be added to Fusion 360. You can see here that there's a whole bunch of operations. In this case, the first operation that I want to use is just a simple face operation, and I can select that from either the icon at the menu or from the drop-down box by choosing face. The dialog box opens up, and predominantly the only thing that I'm going to do here is choose select and go and choose the tool that I'm going to use in this instance to do the face milling operation. So this is the tool environment where I can select all of the tools that I have available to me. This is filtered at the moment, so I can go through and choose maybe tools that I've set up that are specific to alloys, aluminium alloys. It's only choosing mills that tools that I've assigned as being a facing tool, and again the tool type is specific to face mill. You could then further go through and refine that. So if you had 20 different tools or face mill tools available to you, you could go and choose based on diameter, flute length, coolant, number of flutes, etc., etc. You can also, in this environment, create a new tool if you wanted. So if the tool that you wanted wasn't available, and maybe you were going to purchase a tool or you had purchased a tool, then you could go new tool, which would bring up a dialog box here where you can go through, specify the type of tool that it is, the material that it's made from, whether you're using coolant or not using coolant. So there's a whole range of information right through to the physical properties of the component as well. So you can see here there's a whole range of information including feeds and speeds and associated information around the post-processor setup of that tool. But in this instance all I'm going to do is choose the 50 mil face mill and go OK. And I don't actually have to do anything other than that. I can simply hit OK, and that will then run the facing operation. So let's have a look at this one in action. So to simulate your toolpath, there's a number of ways. You can actually see that the toolpath is shown here. If you click off of face 1, we'll actually hide the toolpath. So you have to be able to simulate your toolpath, you have to have that toolpath selected, or you have to have a bunch of toolpaths selected. So in this case I've selected the toolpath, and I can go up to my option here, which is simulate, or I can right click on that toolpath and say simulate there, and that will then bring up the simulate dialog box. So there's a couple of things here that you can do. You can turn on or off stock. So if you want to be able to see the stock material that you're using, you can turn off things like transparency. You can show certain sections of toolpath, the way you display the tool and the tool holder. Otherwise, it's a simple matter of then pressing the play button and watching it all happen. So you can see here that we can watch the material being milled away virtually inside of our environment to make sure that we shouldn't expect any issues with this toolpath that's been generated. So that all looks quite good. Okay, so next operation is we're going to add some adaptive clearing, and like I said before, we've got this big lump of material, and we can use adaptive clearing to quickly machine out the bulk of that. So in this instance, I have a 2D milling operation called adaptive clearing. Clicking on it enables me to run through and set this up. I'm going to go and choose the tool. In this case, it's going to be a 16mm end bit. So actually what I'm going to do is turn off a number of, I've got in my default setup a heap of different bits and pieces set up, so I'm going to turn those off so I can't see quite as many tools when I choose options. So what am I on? Not facing tool. I want a clearing. So here we go. Oh, that's no good. Now it's disappeared. Let's try that again. Okay, so we're just using the tutorial, sample and tutorial tools that have been set up. So in this case, I'm going to choose this 16mm flat tool and go OK. And I'm not going to adjust any of the parameters. I'm going to leave flooding turned on. I'm not going to adjust feeds and speeds. Typically, these would be dictated to you by the tool provider, machine tool provider, where you would enter it in to be a parameter specific to that tool. Further to this, then I'm going to then just select the outside edge of my part, because what we want to do is then mill away all of the material surrounding this component. So I'll choose the bottom outside edge of the component. You'll note that in this instance it's actually indicating it's going to mill the inside of the component, but you can change the direction just by clicking the arrow, and that will then say it's going to mill the outside of the component. I'm going to go across and check a couple of options. I'm going to turn on stock to leave and make sure that that's got some, some material around the outside of the component so that we can then do a finishing pass afterwards, and otherwise just hit OK. And you'll see that it's generating the toolpath for us. It's a reasonable toolpath. The good thing is Fusion 360 is developed around 64-bit operating system, so it can use multiple cores to generate the toolpath. And you can see here that running our toolpath, that we've got an operation that's going through and quickly machining out the bulk of the material of our components. So if we turn off transparency, you can see there the material being removed in real time. Okay, so once we're satisfied that we've set up our adaptive clearing toolpath, then we can do a contour. So now we want to run that finishing toolpath around the outside of our part. So from our 2D operation, 2D contour, in this case we'll use, we'll change the tool. We'll use maybe a 10mm flat, go OK. And in this instance, we'll go and choose our geometry. Again, I'm going to choose the same contour. Now I need to go over and make sure that when I'm that one setting that I had previously turned on, which was stock to leave. So you want to make sure that stock to leave is turned off. If you've left that on previously, then it may be active, but in this case, thankfully, it's turned off, which meaning that we are actually going to mill right up to the edge of our part with no allowance in there. And the other thing I want to do is I want to turn on our entry position. So if there's a specific position that you want your tool to enter from, then you can actually select that. So in this case, I've got under my linking tab an option here to then choose the entry position, and I can choose a specific point around the part and go OK. You'll see here that it's generated that. Now, there's one thing I can see here visually, and this is the advantage of having, the simulate option, is I can actually see the tool is going to mill the wrong side of our toolpath. So I can edit that toolpath at any stage, click on the geometry tab, and then just quickly flick the side that we're going to be milling and go OK. So you can now see that our toolpath has been generated. Our entry point is over near the point that we selected, and we can simulate that again by just pressing our simulate button. I'm going to turn on transparent, hit play. And in this case, because we've only selected that toolpath, it's only going to simulate that toolpath being run, so you won't see the previous toolpaths having been run. If you want to see the group of them, then I suggest you right click on Setup and go down to here, Generate to Simulate, sorry. And you'll then be able to then run through all of those toolpaths collectively. So we've got the facing operation as our first operation. Then we've got the adaptive clearing operation that's going to go out and rough out our component, leaving an allowance around the component. And then we've got the finishing operation that's going to go and finish off our part. Okay, so let's quickly move on. How much time are we doing for time? Okay. Let's spot drill some of these holes. So now we've got a series of holes that we want to drill out. The first thing that I'm going to do in this case is to spot drill a couple of these. So let's do that. So I've got a drilling operation here. I'm going to go and choose, rather than a drill, I'm going to choose a spot drill, choose the size that I want. In this case, we'll choose the 10 mil, go OK. And then I can go onto my geometry tab and I'm going to select, before I select the hole, and it doesn't matter whether I do it beforehand, but I'm going to choose select same diameter. In essence, what this means is that if I choose this hole here, it's going to go and look for any other hole that's got the same diameter and link them together. It doesn't mean that I can't go and choose another diameter hole like I'm going to do in this instance, selecting that hole that just adds to the chain of already selected holes. Further to that, what I want to do is go to my heights tab. Now my heights tab shows me the height planes that I've defined within the context of this tooling operation. So you can see that we've got our clearance height, our retract height, and they're actually visually shown on the screen here. And what we want to do is we want to put in a different height. So in this case, we want to put in our top height and our bottom height. A top height in this instance is going to be the model top. And our bottom height is going to also be the model top, because what we're going to do is we're going to peck down 2 millimeters from the model top. And then in this instance, we're actually just using the drill bit to then peck a hole that we can then use our 10 mil drill bit to then drill through. If we now go OK, you'll see that the operation has been generated. Let's quickly simulate it, press play, and have a look at what it's doing. So you can see here that we've got this operation here that enables us to spot drill those 4 positions, enabling us now to then set up a drilling operation. Now, you've got this operation that's already been created, so I'm going to show you a quick tip for recreating similar operations. So if I right-click that operation, copy, and then paste, I can copy and paste the second operation. If I wanted to, rename this, I could rename it to drill 2 maybe, and then I've got drill 1, drill 2, or I could be a little bit more specific about what each of those are doing. In this instance, what we're going to do is just make a quick change to our drill bit. So we're not going to use a spot drill. We're actually going to use a proper drill. We'll choose a 10 mil drill bit, go OK. You can see our toolpaths or geometry has been automatically selected for us. And in this case, what we essentially need to do is just go through and resolve our height. So we're going to leave our top height as the same as the model top, but the bottom height now is, because we want the hole to go all the way through, will actually be the model bottom. Further to that, I'm also going to make another quick change, and that is to turn on the drill tip through bottom. So if we want the drill tip to extend through the bottom, I can specify how far and go OK. So effectively we've said that the top of the model is our top plane, the bottom of our model is our bottom plane. Now we want the drill bit to extend through the part. We can now click on that toolpath, hit simulate, hit run or play, and you can see here that our part now is being drilled for the holes. Okay, so a couple more things. So we've got some pockets and we've got these larger holes. So let's look at milling these out as well. Oops. So how do we go about doing that? Well, it's quite easy actually. So inside the 2D option, I have a circular option here that I can use that enables me to quickly and easily mill out these holes or cavities in our part. So I can choose, I can even choose a component, or I can leave the 10mm flat that we've already, has been pre-selected for us. And I can then go and choose the circular face that I want to mill out. So in this case, we've already drilled a hole down through the center of the component. So it makes sense then to have a linking operation set up where we're leading to the center. In effect, then we'll be moving the tool up and down the center of the component where we've already removed material and leading in from there. If I go OK, you'll see that we've generated the tool path. Again, I can move quickly to then go and mill out the material in that local area on the component. Let's stop that. Again, let's copy that toolpath. So copy, paste. We've now got a second one. I'm going to edit it. I'm going to use the same tool, same settings. I'm just going to choose the lower section of our component, go OK, and it's generated the tool path for that lower section as well. Likewise, if we wanted to mill out a pocket, so we wanted to mill out these pockets, and it could be the same for the pockets that we've got here as well, you can just go 2D pocket. So we can mill out the 2D pocket. In this instance, we'll choose a smaller tool, so we'll maybe choose a 5mm flat, go OK. We can then choose the geometry that we want to mill. In this case, we'll choose that face. We can go through and make sure our settings are right. Our heights, we don't need to make any changes there. We're not going to leave any material, so I'm going to turn that off. What else can we do? Let's just go OK and see what happens. So you can see here that we've then generated our toolpath. Let's run it and have a look at what it's going to do. So you can see here it's moving down the part, removing material, and then when it gets to the correct depth, it'll then move through the component, milling out the remainder of the material that we have on our component, doing a finishing cut as the last operation. So in all, let's run through and simulate the whole part and make sure that we've got some resemblance to what we would expect to happen. So right click, you can generate the toolpath and it'll regenerate all of the toolpaths that have been created. You can then simulate your design. Again, we'll just do this very, very quickly. Turn off the transparency so that we can see a solid block of material. We can speed up and slow down this simulation to see our part being machined in a virtual environment long before we've actually put anything on the machine. And you can see here we're going through now. We've done our drilling operations. We're now doing our milling operation, our pocketing, and we're done. So very quickly and easily we've generated that, that setup. Now there's a couple of other operations that we could have done. We had to do the pockets here. We had to add a chamfer around the edges. But further to this, if you then wanted to take it to the next step, you might have to turn this component over and then face mill the other side. Well, that'd be really easy because there's nothing that you really need to do other than creating a new setup. So we can create a new setup here. I can choose the model that we're going to use. We can specify the stock. So we just use the same settings as we previously used, or if we've modified the stock size, then we can go and put a fixed size box in there. And then we can go and then put our facing operation on there as a second setup. So we could have our first setup as machining one side of the component, flip it over, set up our second side of the component, face mill it off in this case because there's no other real milling operations that need to be done, and we're finished. Okay, so let's go back to our presentation and have a look at some of the other functionality that's available to, oh actually before I get out, there's two important things. So we've looked at simulating our toolpaths. The other thing is we can post-process our toolpaths and we can generate a setup sheet. So let's quickly generate the setup sheet. I'm going to choose the folder I want it to go into, and in Chrome it's opened up a HTML setup sheet. So this setup sheet shows all the information specific to the job. So we've got our setup job description, we've got our document path of what the file is named. We've got stock size, coordinate systems, we've got the coordinate system locations, we've got the number of operations, the number of tools, the tools that you need, the maximum Z and minimum Z directions, the feed rates, cutting distance, rapid distance, estimated cycle times, and then if you go down we've got a whole range of tools that we're then going to use and all of the specifics associated with them. So you can see here that there's that this is actually quite a comprehensive and useful tool for anyone that's running multiple jobs in their environment, enabling them to quickly access effectively all the information that they would need in being able to set up their machines for jobs going through the shop. Further to this, we can then generate our or post-process the job. So in this case I can go through and I can set this up. I can set up where I want all my posts to go. I can choose the type of post that I'm going to use. In most cases you would set this up and maybe only change it for the machines that are specific to what you're using. But I've got a whole range of standard posts that are available to me. In this case just I've narrowed it down to just the milling posts. So I can choose the type of post that I want to use, the output folder, the output extension. I can give it a program name that's specific to this file. I can choose document units, whether it's going to be in inches or millimeters, and go post. It'll then post this information then for us, and you can see there that it'll generate the code for you. Now let me do, because it just kicked up an error. Let's see if that fixes it. So here's our post. I've just chosen a default Haas post. You can see here's the start of our post, talking through all the various settings that we've got, then all of the operations. So here's our first facing operation. Here's our adaptive clearing operation. That'll be quite a long operation because there's numerous positions for the tool. And then you'd be moving down and then looking at all of the other operations that we've got thereafter. Towards the bottom, we've got our drill operations, circular operations, and this is in an editable format. So you can actually come in here and edit this document, add, remove information as you feel is required. Okay, so moving on, let's move back to our presentation because we've got quite a lot to get through. So okay, so the next feature that I want to show you inside of Fusion 360 is the turning capabilities. So not only do we have milling, but we also have turning capabilities. In this instance, I'll show you how you can quickly create a job setup. You can generate toolpaths, including facing, profile, grooving, and drill operations. We'll look at simulating our toolpaths, creating a setup sheet, and then generating some G-code as well. So in this instance, we have a sample part. I'll flick back into Fusion 360 and open that part up, which is this one here. And then let's run through quickly how we set this up. Now we're running very, very late, so I'm going to be very quick here. It is very similar to the way that we set up our part for milling. So it's in the CAM workspace. I go to my setup area. In this case, instead of it being milling, I'm then moving over to turning or mill turn. I can then choose how I want my coordinate system to be displayed. I can choose entities actually to define the coordinate system. I can flip axes if I want it to be. I can define the x-axis. I can define the home position. I can define the stock front. And then I can go and define the stock. So in this case I can use either a fixed size cylinder, or like before, we can use a relative sized cylinder, which will then offset, adds an offset radially to the component, but then I can add a front side offset as well to the component. So 0.5, and this is in imperial. If the component is in the wrong direction, then I can flip things around. There's no problems there. And go OK. And we've just defined our setup. So here's our part defined in the context of our stock material. Now we can start using our turning operations like we saw before, and I'm actually just going to turn on more from my library of tools. I can go in here and from my turning operations, so we've moved out of our 2D operations into turning, I can then choose to face the part. I can select the tool that I'm going to use. In that case, I'll just use the default tool and go OK. And that's it. That's all we need to do in that case. Sort of very similar to when we're using milling. There's very little we need to do. We can then simulate this and what's going to happen. So you can see here that we've faced, there's our first facing operation showing the front of our component. Further to that, then we can do a profile. So in this case, we'll turn to turning profile. And there's a couple of things that I can do. So I can go through and choose the tool. In this instance, we'll use the same tool again. You could change that. I'm going to turn off allow grooving and then just go OK. And you can see here that what it's done is it's generated the toolpath. Now, if I'd left allow grooving on, you can quite quickly see the consequence of doing so. It would have actually cut back into the material again to try and remove in this localized area some of the material, but there's no need for us to do that because we'll have that as another secondary operation. Again, all of these environments have got the ability to be able to go and select specific areas. So if you wanted to confine this to a local area, then you could do that. If you want to specify clearances, define your passes and the way that roughing is handled. In this case, we actually have it. This is a roughing pass. But you can also then have linking of various different passes as well. Further to that, and this is where I can show you another option, is create a derived operation. I can in this instance create a derived operation which will be a subsequent profile, a turning profile operation that will happen after our previous one using the previous settings. So very similar to the copy and paste option I showed you before, where I can add that. You can see here now we have profile number 2, and we can go through, we've specified all of our settings. In this case though, I'm going to turn off the roughing pass, and I'm not going to leave any stock to leave, and go OK. And you'll now see that what it's doing is it's actually going to run through and do a final or a finishing pass on our part. So you can see there it following or tracing around the path that we'd previously cut. To cut out the area of material that we've still got in our part, we can then use a groove functionality in this case. So go to my turning groove. In this instance, we can choose the groove tool. I'm just going to choose a standard tool from our library to use there. We'll go to our geometry tab, and this is going back to what I said before. You can choose confinement, which enables you then to choose the localized faces that we're going to mill in this case. We'll make sure that we've got a couple of settings turned off. I don't want to have any roughing passes. I'm not going to leave any stock in this case either. We'll go OK, and we can see here that our tool paths have been generated in that local area to take out the material. So if we now run through and generate the tool path, right click, simulate, and then run this, you'll see that we've got a whole bunch of operations that are going to turn this component out of the stock that we've defined. So if I turn off transparent, you'll actually see better definition of the part being created. We could add subsequent operations to turn out the inside or drill the center of our component, but you can see there very quickly and easily we have a number of operations that are making our component. Okay, so we'll go back into our presentation, and likewise, just actually before I do that, likewise, if you needed to generate G-code or you wanted to generate a setup sheet, again, I can specify the setup sheet, and you'll see here's our setup sheet that's been defined, all of the information associated with the setup of this job, including the stock size, the time to machine the component, and all of the tools that are required to machine this component. So very easy and quick for you to generate that kind of information. Okay, so just quickly, water jets, plasma, and laser cutting. Yes, you can do this inside of Fusion 360. It is a somewhat manual process. I'm going to show you through this. That includes aligning and positioning parts, job setup, toolpath generation, simulating your toolpaths, creating setup sheets, and then generating G-code. So let's have a quick look at this. So here we are inside of Fusion 360. I'm going to open up a little stool that we can maybe laser cut out of wood, and so here's our part. So Fusion 360 doesn't have nesting software. It's not a nesting. It doesn't have any nesting capabilities at the moment. If you're looking for nesting capabilities, there is a product called TrueNest that is an Autodesk product. Works with a whole range of products, including Inventor, and it will do effectively almost anything that you need it to do when it comes to water jet, laser, plasma cutting, and even turret punch fold machines as well, including nesting and programming all the code, and it's completely automated. Now, Fusion 360 is somewhat a manual process in laying out your components, but you can do it. Now, the first thing you need to do is under your login, under Preferences, turn on, down under Preview, the option for CAM, water jet, laser, plasma cutter support. And the reason why you need to do this is because by default there is no actual capabilities. This is like a beta option for you to be able to test and trial laser cutting or water jet cutting operations with inside of Fusion 360. So if you don't see it, that's the reason why. If we go down to our CAM workspace, we've got our part. Now, actually, before we do that, we need to orient our components. So I'm going to move them by aligning components. So I'm going to align this component with that component. If it aligns them the wrong way, I'm just going to flip them over, and then I'll do this one and that one and go OK. So we've now aligned our components. Let's move them into position. I'm going to rotate around, so I'm looking down from the top of my part, and I'm going to move this one here. I'm going to rotate it so it's upside down, and then I'm going to position it relative to one of the other components and then go OK. Remember, you can right click and drag up to repeat the previous operation, in that case a move, and then we can drag this seat component out in space and position them. So we've given them a little bit of space relative to one another, but effectively now our components are set up ready to be laser cut. So let's switch to the CAM environment, and you'll note that, like I said, we've got our water jet laser cutting operations there. First thing we need to do though is still create a setup. So you still need to create your setup like we've done before. We need to choose the type of setup we're using, in this case water, laser, plasma. We can choose the model orientation, or we can select the Z-axis. Again, our Z-axis is actually in the wrong direction. In this case, we want Z up. We can choose our X-axis. Maybe X-axis is going to be that one. Choose the models that we want to cut, which is those three. We can move inside of our stock tab to find a fixed size box or a relative size box. So if we wanted to, we could have 10 mil clearance all the way around. We don't want to have a top offset, and just go OK. And now we have our stock set up. We can then move into the water jet operation, where we can create the water jet, laser or plasma. So in this case we'll choose laser. We've got an option for adjusting its curve, the kerf width, and also the feed rates of the cutting process. We can then go through and select our geometry. So you'll see here that we've got the option of choosing a range of geometry on the edges. We can add tabs, so if we don't want the components to break off of the surrounding material, we can add a tab. Maybe it's going to be a 5mm tab. We can have them automatically added at 80mm distance apart, or we can manually define points that we want to add tabs. So maybe we want to add a couple of tabs to each part just to hold them to the support material in those locations. We can add them quickly and easily. We can work through heights and passes and linking, but otherwise I'm just going to go OK. And you can see here that we've generated our toolpath. So let's simulate the toolpath and have a look. So let's hit play, and you'll see here that we've got our laser cut process to cut out the components of our seat. The tabs are the areas that the laser won't be cutting, and it'll be just leaving that component in that localized area. And you can see that it'll automatically recognize sections that need to be cut inside other sections. So when a component is nested with inside of another component, it will cut the inside profile before the other ones. Otherwise, then you can do as we've done before, export a setup sheet and then generate or post-process the G-code associated with having your machine run this toolpath. Okay, back to our presentation, and let's move in now into the 3D printing aspect of our presentation. I'll try and keep this short, about 10 or 15 minutes. A little bit about Autodesk's involvement with 3D printing. I'm not sure whether you know, but Autodesk has created a platform called Autodesk Spark, and it's a platform that is being developed in the 3D printing space to help further the growth of 3D printing. It's a technology that comes embedded inside of Windows 10. It's also being used on a number of other platforms, including the Ember printer, which is the Autodesk printer. It's not really a commercial printer in the sense that it's not out there to compete with the likes of MakerBots and Stratasys and those sorts of things. It's more of a platform for research and development, but it is available to purchase if anyone's interested in that. I love watching these types of videos. This is actually the Ember printer printing away, creating a component. This is sped up, this video, so it doesn't happen quite that fast, but you can see here that we can create very intricate details using that printer. So what about 3D printing in Fusion 360? Well, as such, Fusion 360 doesn't have any 3D printing, but it works well with 3D printing, and that's what I'm really going to show you in this instance, and that is how you can export your geometry, including things like mesh preview, refinement of your mesh, and the output of that, and then working with a product which is called Autodesk Print Studio, which is a product that's available for you to download and access today if necessary, where you can lay out, repair, generate supports for your part, preview, and then export components to be printed. So let's jump into Fusion 360 and quickly walk through an example of how you can use this technology. So I'll open up a little gas nitro buggy engine, and we'll use this as an example. So I tried to pick out a part that would be reasonably hard to print, and I thought that this one here actually is one of the harder ones that I've seen, because it's a reasonably organic shape. There's no real flat surface for it to sit on, so it might be hard for you to position and optimize it for 3D printing. And that's what it's really about. It's about making sure that your part is optimized so that it prints first time successfully. So there's a number of things that you can do. You will notice that if you go into the model environment, you've got a make option here, and that make option enables you to then 3D print. The problem with doing this in this instance is that you would actually be 3D printing all of these components, and there's nothing wrong with that, but in this case we just want to print one component. So the way that we do it is we activate that component. So if I click on the component, you can see here that I can activate that component, and whilst it's still selected, I can then go and 3D print, and that will then just bring in this component. You can see here that If I then go and preview the component, it will then generate the mesh that's required to create the component here based on the settings that we've used, and it's disregarding all of the other geometry inside of our part. So you can see here, here's the number of mesh elements that have been created to generate this mesh. I can change the refinement that I'm using either with some default settings or I can manually go through and define these if I want to be a little bit more specific about the output type that I want to use. And it's great because you've actually got sliders there to use. Now, if you just want to save that as an STL file and import that into a 3D printing, then you can go OK. You could have just right-clicked that body in as well and said export to STL, which you would effectively have brought up the same dialog box. But if you want to then bring it into a number of custom utilities such as Print Studio or Autodesk Mesh Mixer, then you can bring those in and have them automatically transferred into that environment. So let's do that. Let's use Print Studio to print this component. So typically, Print Studio is opened up on the wrong monitor, but here it is here. You can see here it's brought in our exhaust manifold inside of Autodesk Print Studio. Now, I'll try and give you a very quick run around on this product. So again, it is a separate download for you, but you can access this at the moment. You can set up the type of printer that you want to use. In this case, I've chosen the Autodesk Ember printer, but you could use any number of different commercially available printers. And if your printer is not there, then you can create your own specific printer. And you can also connect to printers, either using a network or a USB connection, and hit your connect button. There's various settings associated with that printer that can be modified as well, so I can choose the type of material that we're using, the in this case the size of the material, the print quality, and then I can also duplicate a profile, and with inside of these then there's a range of different settings that are accessible where I can go through and turn on or off various different parameters associated with the component. Now this will, depending upon the printer, different functionality will be available here. So you can modify, in some instances, 100 or more parameters associated with the print, making sure that once you've got the setup for the types of parts that you're printing and the materials that you're using, then you can quickly replicate that, ensuring that your prints are successful. Okay, other than that, our component has been brought into this environment where we've got our print envelope, and you can actually see that. It shows the print volume of our component, and it's placed it within inside that space. We can manipulate the geometry, so I can move around, I can select the part that I want to move, and I can move that component just by dragging it around the workspace and rotating it. Now you will notice that the part will change to transparent if I drag it outside the print space. So you can see here it changing. That to indicate that the component has actually shifted outside the workspace. You can move the component to the center of the workspace. If you've dragged it up, like we had there, you can move it to the bed as well. And you can also choose auto layout. So if you've got a whole bunch of components inside of a print environment, you can choose auto layout, and it will automatically lay out those for you. Likewise, if you've got a bunch of components, then the object browser becomes in handy, because then you might have a whole heap of different components that you're trying to use. Otherwise, you might want to hide that if you've only got one like we have. You can scale your parts by quickly and easily dragging them up and down. You can scale them to fit the print volume as well, like we have there. We don't want to be quite as big. And you can also lay flat. So if you wanted to lay the component in a specific orientation, you can see here that you can choose any number of orientations to check your component and locate it in. Once you've done that, you can then repair the component, and you can actually see that this component has imported with a couple of errors. The good thing is you can isolate and inspect those, so you can see here that it's highlighted a couple of errors for us. If we rotate around, we might see them. Either way, it doesn't really matter, because we have an auto repair option. If I click on that, it will then automatically repair any geometrical issues that we have with the part, so there's really no need for us to worry about doing this. The one thing you will note, if you get a little bit, you know, you've auto-repaired your part and then you think, okay, well, where'd the menu across the top of my screen go? It's because in moving into the repair environment, you've actually shifted into a completely different, effectively, workspace. To exit that workspace, just go down to here and click on that icon and it will bring you back into the other workspace. But you can also do other things like crop the part, you can patch holes, you can split or cut your component, you can balance it, you can move it and select it, you can do a whole bunch of different things. But other than that, the only real things that I want to show is the fact that we can now then go into this supports area and we can automate the process of aligning our component in the most optimal position or rotation, and then adding the supports as an automated process as well. So if I click Optimize Rotation, it'll assess the component and look at the best orientation of the component based on the type of printer that you're using, the type of material that you're typing to print, and the restrictions of printing with those. Some general practices around 3D printing, such as overhangs, angle of slope, and then the need for adding support. So it's actually oriented the component in this position for us, believing that that's the best print orientation. Now the problem is it's not going to print like that. It's not stable enough. So we need to add supports to stabilize the component and allow it to print any overhangs that the component has. So if I click Add Supports, you'll see that, and this actually process can take a few moments to happen, but it will automatically go and add those supports for us. And this is a timely moment for me to grab a very quick mouthful of water. And you can see here that it's generated all of the supports. Now the one thing that has happened as a result of doing that is the material has gone transparent, which means that the component is outside the bed. You can see it, the support material is actually outside the bed. So what we might need to do here is just quickly modify this one. Come in, we can make a slight change, rotate our part around slightly, making sure that it fits within inside of our print envelope, and you can see here now our part is opaque, meaning that it should print successfully. We've generated all the supports. If we wanted to, we can move back in and add supports as a manual process. So I've got manual supports down here where I can choose, say, a point on the bed, floor, and then a point on a part, and I can add a support to my component like that. Okay, once we've done that, we can hit our preview button, and the preview will then generate all of the toolpaths associated with the creation of this component, remembering that these 3D printing processes are typically made of a layer type system where it's building up the component layer after layer. In the Ember printer is no different. I believe it uses an SLA type process. And you can see here that, again, it takes a few minutes to generate. Thankfully, it is using quite a lot of my computing grunt to generate this. And you'll see here that all cores are running at 100%. So the better specification machine that you have, the faster this is going to do. But that's the benefit of having 64-bit technology. And given a few more moments, we then should have, so here's our slices showing a preview of the part being built up over time. You can see each layer that's going to be built through our component. And then we can export the file to our printer, save it out, and then import it into the printer to be printed directly. So you can see here, very quick and easy, very intuitive, but very powerful at the same time, enabling you to generate 3D prints that can be successfully printed first time. So let's just quickly cap off with some further reading. The forums, Fusion 360 is heavily supported by the community, both internally and externally. There's a lot of customers that are using Fusion 360 and collaborating on the forums together to answer questions, but the R&D team are also, or development team are also supporting a lot of those inquiries on the forum. So if you have questions that are specific, feel free to contact them through that method. There's also a Twitter account for Autodesk Fusion 360. If you're a Twitter user, maybe worth following that. If you're a Facebook user, there's also a Facebook account for the Fusion 360 team. And likewise, there's an Autodesk Fusion 360 channel on YouTube showing all the latest Fusion 360 technology. Locally, we have a Future of Making Things group inside of LinkedIn where we're talking about a whole range of different bits and pieces. It's not necessarily specific to Fusion 360, it's talking more manufacturing, technology, the future of making things. So please, if you're a LinkedIn member, go and join that group. Again, if you've got any questions, my contact details are there, matthew.mcknight@autodesk.com. My mobile number, feel free to reach out and contact me. Otherwise, we also have another webinar coming up in a couple of weeks' time, Fusion 360 for SolidWorks users. Feel free to use the short link there to sign up for that webinar. I'll hold that up there for a few more seconds. Maybe you can grab a screenshot, a print screen, or otherwise, if you're looking for some further information about Fusion 360, if you're an active subscriber of Product Design Suite, you get Fusion 360 with your subscription. So if you want to find out how you can activate that, just do a Google search for Fusion 360 Access for Product Design Suite subscribers. That will step you through the process. Otherwise, I will look through questions and answer any that may have popped up at the end of the session. But otherwise, I thank you for your time and your patience. I know we've gone a little bit over. I apologise. Hopefully you found value in the content that we delivered today, and hopefully we'll see you again. Otherwise, enjoy the rest of your day. Bye now.